7.5? Perhaps. I need to get this one out of my system, so I'll try to get through this one fast. Again, this is the one I was at the end of last class. I did something unhelpful, made a mistake, and I need to try to fix it. So it was 30, what did I say? It was number 37 of, 37 of 7.3. We're supposed to prove, I'll state it this way, why is it the case that sine 2 theta divided by 1 plus cosine 2 theta, all right, times tangent squared, why is this equal to tangent cubed? We're so basically supposed to prove this identity, right? So this was the one I messed up at the end of class. This is section 7.3, number 37. So I'll ask you guys, what do you think I should do here? What identity on our handy-dandy identity sheet might be helpful? That's the one I handed out last time. And I also handed out these. These are, I talk about this, the arctan2 function, which is maybe of interest to you, computer science folks, in terms of like a function which actually calculates the angle of a point in the plane. So it's like a built-in function for certain programming languages. It took me a while to find it, but it's called atan2. It actually calculates the angle of, x comma y. Notice the format here, y comma x. I'm annoyed by that, but anyway. And there's a few other pictures in here which I just thought are interesting. This is just for your information from Wikipedia. I think these are kind of nice summary, either summary tables or the pictures are interesting for proofs that I've proved in a different way. All right, so I asked a question. What identity do you think I should use here? Does anything look like that? It's kind of like 23. Ooh, excellent. 23. That is what we should have used. So this, by 23, we have that sine 2 theta over 1 plus cosine 2 theta times tangent squared theta. Well, that is literally the tangent of 2 theta over 2. Which is exactly, which is just tangent theta. So of course this is tangent cubed theta. So this is how this problem should be solved. Whatever I was doing at the end of last class, it shows you how hurrying doesn't save you time. It wastes your time, right? So, of course that was on purpose. You're welcome. So which one did you want me to work, Jared? Anything from 7.5?
Like 5 would work.
5? All right, 5 from 7.5. Let's go there. Number 5 from section 7.5, we're supposed to solve 2 sine theta I'm saying theta, it might have x, I don't know. 2 sine theta equals to the square root of 3. And we're supposed to do what? We're supposed to find all solutions from 0 to 2 pi. Right? All right, so first order of business, I would rewrite this as sine theta equals to the square root of 3 over 2. Aha! This is a known quantity. We already know this. This is a standard angle. This implies that theta equals to pi over 3, or 60 degrees, right? You could also use your calculator. You could use your calculator. Inverse sine of root 3 over 2 should give you 60 degrees, or pi over 3 radians, right? Now, we're supposed to find all solutions, though, right? So is this all solutions? Well, there I would advocate thinking graphically, right? So what's sine look like on 0 to 2 pi? Looks like this, right? So we're solving where sine theta is equal to the square root of 3 over 2. So that's asking the question, where does the sine theta graph intersect the horizontal line y equals to the square root of 3 over 2, right? Where does that happen? Well, we know one place it happens because we know the standard angle, right? So look, we're saying pi over 3. That's this guy. My graph's not quite to scale, right? The point is, if you did this carefully, you should see that there's a symmetry, right? Between the graph of sine is symmetric with respect to like its its maximal point, right? Like, so you could look at it different ways. You could say that the other solution is the same distance from pi over 2 as pi over 3 is, or I think what's easier is to notice that this one's pi over 3 from the 0, so the one over here must also be what? Pi over 3, right, by the symmetry? So what's the point where it goes through 0? Well, that's pi, right? So the other solution, theta equals to pi minus pi over 3, also known as 2 pi over 3. That's the other solution. And that's it. So you either got 2 pi over 3, or you got pi over 3 radians. Them's your solutions. Now, Jared, this is a good question, but I'm going to reroute your questions back to section 7.4 to 7.2, because actually I'm not testing on this in the quiz today. So,
Don't even worry about it then.
so do worry about this. This matters. This will be the lion's share of the next quiz, probably. But it is important. It's just not as important today.
Worry about it.
Yeah, right. Because like 7.5 is next level. It is using all the identities and everything that we have to solve equations. So it's kind of the next step in the thought process. We're not quite there yet. Even if my course planner says we are, we're not. So I'm just doing the best I can here day to day. So let's go back to 7.4. Why don't you guys ask me one from 7.4? Here, I'll do number 5 from 7.4. So here, 16, sine of 16x, sine of 11x. So this is a what? This is a product of sines, right? So I look for the product to some identity. The sine one is number 25, all right? So this is equal to 16 over 2, and then parentheses the cosine of, how's it go? Alpha plus beta over 2, so in this case 16x plus 11x over 2, and then times the cosine of the difference. So cosine, it could be plus rather, right? Not times, plus, product of sum. So plus the cosine of 16 minus 11x over 2, right? So what's that give us? I keep forgetting to bring new chalk from home. It's driving me nuts. All you guys are these stupid nubs. Driving me nuts. Oh man, how did I had somehow the camera. Sorry to people who are not here, but anyway, there's from the start. All right, so, So we've got 8 times the cosine of, let's see here, 16 plus 11 is, so 27x over 2 plus, 8 cosine of, looks like 5x over 2. There you go. It doesn't have to be complicated, right? What other one would you guys like me to work in here? Number 38. 7.4, number 38. Prove the identity. Cosine A plus B. So we're supposed to calculate cosine of A plus B plus cosine of A minus B. So I'm just going to go ahead and work on that and see if we can get to the thing that's stated in the problem, right? We're supposed to basically simplify this. And supposedly it simplifies to 2 cosine A cosine B, all right? I'm not even going to write it. Let's just work on this. So first of all, cosine A plus B is what? Cosine A plus B is cosine A cosine B minus sine A sine B. Right, that's this, by the adding angles formula for cosine. And then, what's the other one? Well, we got cosine A minus B. So it's very similar. You get plus cosine A, actually I'm going to write it below. Cosine A cosine B plus sine A sine B. That's the identity for, when we have subtraction, it changes the minus to a plus in the formula, yeah? So what happens when you add these? The sine terms cancel, and you get 2 cosine A cosine B. There's a problem we haven't worked yet that I think might be instructive. Oh, do you have another one that you have in mind?
I thought 53 was just funny. You want me to know?
53? Sure. 7.4, number 53. So we've got sine x cosine 15x. What did I just say? Sine x.
Sine x cosine 15
And what's the next term?
minus cosine x sine x. And for the problem before, would you leave it in cosine A plus B plus cosine A minus B?
Well, the problem before is to show that cosine A plus B plus cosine A minus B is equal to 2 cosine A cosine B.
Okay.
So it's an identity problem. This is a simplify problem, right?
Yes.
Yeah. They're very similar, but it's just a different way of asking the same algebra, right? I mean, but anyway, simplify here. Prove the identity, it's more structured in the sense that it says simplify, but simplify this way. So it's actually easier, even though it's got the word prove in it. This one's easy, though. This is just sine of x minus 15x. And that's by formula 12. So read formula 12 right to left, right? Be aware that these formulas can either applied starting on the right-hand side or starting on the left-hand side. You do have different ways of, and so this is just sine of minus 14x, which you could, if you prefer, write as minus the sine of 14x. I mean, I'd like that answer, but. Now, so just one more example I'm going to try. I want to see if we can simplify, let's say, sine cubed of x, of theta. So I did a cosine to the fourth in a previous class, so I'm trying to do a similar thing here. I want to expand it in terms of just sums of sines or cosines. All right, and so like this is sine times sine squared, right? So I could also write that as sine theta times 1 minus cosine squared theta, yeah? Great. And then, well, actually, I regret the last step. Why do that? How about we just go back to the previous step? That's not helpful. What I just did is not helpful. Not helpful. But we could go from here to something nice, right? This is just sine theta times 1/2 1 minus cosine 2 theta, right? By formula 19. It's the one of the half angle formulas. This one, again, I mentioned was very important for calculus too. Okay, so we got, what do we got? We got 1/2 sine theta minus 1/2 sine theta times the cosine of 2 theta. And so you could leave that as an answer, right? We have no powers of sine, or if I said, just write it in terms of sine and cosine not raised to powers, perhaps we have it. Let's see here. Could we simplify this any further? Like cosine 2 theta, how can we rewrite that? Well, nothing more comes to mind at the moment. Just a sample calculation kind of thing we can do. All right. I'll try to come back to sine cubed in a future class. I feel like there's something more to say here, but I mean, I did the cosine to the fourth example, right? So there's something similar on your quiz, but the key is basically using the half angle identities, right? So you must know cosine squared theta is 1/2 1 plus cosine 2 theta, right? And sine squared theta is 1/2 1 minus cosine 2 theta. So these two are like some of the more important trig identities in the pantheon of trig identities I've shared with you this semester so far. All right, so I'm going to give you your quiz. I want to make sure you have time. So yeah, I've got sine to the fourth on the quiz. Yeah, sine to the fourth is sine squared times sine squared. So right, so you exactly take that, and we use this identity over here like twice, but then even after that, you still got some algebra to do, and it's like it's not just that, but it's that plus a few steps. So I'll leave the rest of it here, doesn't matter. So there you go. Some of these problems are pretty easy. There's 10 problems, I think, but a lot of them should take not a lot of time. No card? No card? Oh, okay. It's like. Haven't we all? All right, well, enjoy. If you're not here, you need to take this quiz today.